Welcome to Through Inquisitive Kids, and this video will be about comparing linear functions word problems. Antoine wants to get a subscription to a local library. There are two libraries, each of which charges a monthly subscription fee plus a fee for each book loaned. The first equation gives the monthly cost in dollars of joining the first library as a function of the number of books loaned. The monthly cost in dollars of the second library as a function of the number of books loaned is given by the following table of values. Which library charges more for each book loaned? Choose one answer. A, the first library. B, the second library. C, they both charge the same for each book loaned. Okay, so to find out which library charges more for each book loaned, we know that this equation about the first library already tells us that each book is charged $1.5. So all we need to find is how much does the second library charge for each book loaned. Let's take a look at the table. If we go from 2 books to 8 books, that's 6 books. The cost increases by $10.50. From this, we will know that 6 books is equal to $10.50. To find out how much one book is, we just divide both sides by 6. So one book is equal to $1.75. Since 1.75 is greater than 1.5, the second library charges more for each book loaned. So that will be B. Which library has a cheaper subscription fee? So the subscription fee in this equation would be 10. So all we need to worry about is finding the subscription fee in this table. So we know that one book is equal to $1.75. And it says that 2 books is equal to $15.5. So in the 15.5, there must be the amount of subscription fee. All we need to do now is subtract the cost of 2 books from $15.5, and then that will be the subscription fee. So 2 books is equal to $3.5. And since it says here that it's $15.5, we just subtract 3.5 from 15.5, which is $8. And we can see that $8 is less than $10, so the second library has a cheaper subscription fee. 2 submersibles, one red and one blue, started rising toward the surface at the same time. They each rose at a constant speed. The red submersible started rising from an altitude of 80 meters below the surface. After 30 seconds, it was 60 meters below the surface. The following equation gives the altitude in meters relative to the surface of the blue submersible as a function of time in seconds. The red submersible started rising from an altitude of 80 meters below the surface. After 30 seconds, it was 60 meters below the surface. The following equation gives the altitude in meters relative to the surface of the blue submersible as a function of time in seconds. Which submersible started rising from a higher altitude? Choose one answer. A, the red submersible. B, the blue submersible. C, they both started from the same altitude. So we know that the red submersible started rising from an altitude of 80 meters below the surface. And from this equation, we can see that the blue submersible started rising from an altitude of 90 meters below the surface. The negative 90 means 90 meters below the surface because this is meters relative to the surface. And which submersible started rising from a higher altitude? Of course, it's the red submersible. Which submersible rose faster? We know that the blue submersible rose 0.6 meters per second, and the red submersible will have to write our own equation for that. So we know that our red submersible started from 80 meters below the surface. After 30 seconds, it was 60 meters below the surface. So in 30 seconds, the red submersible rose 20 meters, which is 80 minus 60, which is 20. In 30 seconds, per how many meters it rises per second. And in the time range of 30 seconds. And we'll say that X represents how much meters it rises per second. So now we have our equation down. And if we simplify this more, we'll get 20 is equal to 30x. And to solve for x, we can divide both sides by 30. And we'll get x is equal to 2/3. So x is 2/3 meters, is 2/3 of a meter, which means that per second, the red submersible rises 2/3 of a meter. If you divide 2 by 3, it'll just be 0.66666, and that keeps going on. And this is still greater than this, which means that the red submersible rises faster. Heloise considered 2 types of printers for her office. Each printer needs some time to warm up before it starts printing at a constant rate. The first printer takes 30 seconds to warm up, and then it prints 1 page per second. The printer duration in seconds of the second printer as a function of the number of pages is given by the following table of values. Which printer takes more time to warm up? So we already know that the first printer takes 30 seconds to warm up. And this problem is very similar to that library problem we did in the beginning. So we know that from 40 to 60 seconds, which is 20 seconds, we have 16 more pages. So in 20 seconds, 16 pages are printed. So 16 pages is equal to 20 seconds. And since we already know that 16 pages is equal to 20 seconds, and over here it says 40, which means that there's an extra 20 seconds, and that 20 seconds is how long it took to warm up. So that's 20 seconds. The first printer takes more time to warm up. Which printer prints more pages in 100 seconds? Let's see. So in 100 seconds, so for the first printer, we've already used 30 seconds out of the 100 seconds, so we only have 70 more seconds left. And since it prints 1 page per second, we'll have 70 pages. And we've already used up 20 seconds out of the 100 seconds in the second printer, so we only have 80 seconds left. So we have left to print out pages. We can just use this equation over here, so we can multiply both sides by 4. That'll give us 80 seconds. As you can see, the first printer can print out 70 pages in 100 seconds, while the second printer only can print out 64 pages in that same amount of time. So the first printer can print out more pages in 100 seconds. Here's our last problem. So we can see that Isabella can fill 23 liters per minute, and from this graph, we can see that Henry fills 25 liters per minute. And since 25 is greater than 23, Henry filled his pool at a faster rate. And who filled their entire pool first? It took Henry 10 minutes, because 250 divided by 25 is 10. And it would have taken Isabella about 8 to 9 minutes to fill up her pool. So Isabella filled her entire pool first. I hope you learned something from this video. If you have anything to say, put it in the comments below. Hit that subscribe button for me. Thanks for watching, and I'll see you in the next video.